look up. On a clear winter night, find the constellation Orion. The hunter, see his shoulder? That reddish pulsating glow, that is Betelgeuse. It is not just any star. It is a red supergiant, immense, unstable, and it is nearing the end of its spectacular life. Betelgeuse is a cosmic firework, primed for a grand finale. We watch, we wait. The universe holds its breath. And so do we, gazing at this distant, burning ember that once blazed with unimaginable fury. Its story is one of power, change, and an impending, glorious demise. This star is colossal. So large, in fact, that if it replaced our sun, its surface would extend beyond the orbit of Jupiter. Think about that. Earth, Mars, even the asteroid belt all swallowed whole. Betelgeuse is a celestial behemoth. But its great size comes at a cost. Such massive stars burn through their fuel with astonishing speed. They live fast, they die young. Cosmically speaking. Betelgeuse is in its twilight years. It has exhausted the hydrogen in its core. Now, it fuses heavier elements. This process cannot last forever. The star is fighting a losing battle against gravity. Betelgeuse's final chapter may have already been written. For millennia, humans have gazed at the night sky. They have charted the stars known. They have woven them into myths and legends. Betelgeuse, with its distinct reddish hue and prominent position, did not escape their notice. Ancient cultures across the globe saw it. The Aboriginal people of Australia incorporated it into their oral traditions. Tales passed down through countless generations. In ancient Egypt, it was associated with Osiris, a god of the afterlife. Its variable brightness, its occasional flickering, they likely added to its mystique. It was a celestial actor playing a role in the grand theater of the heavens. Its performances noted by keen observers. The name Betelgeuse itself is a whisper from the past. It derives from the Arabic Yad al-Jawsa, meaning the hand of Orion, or, through a mistranslation, the armpit of the giant. Ptolemy, the Greco-Egyptian astronomer, catalogued it in the 2nd century AD. He described it as reddish, just as we see it today. But some ancient texts offer intriguing, perhaps conflicting accounts. There are suggestions that its color might have appeared different to observers in antiquity, perhaps more yellowish. Could the star have changed its visible characteristics over human history? In late 2019 and early 2020, Betelgeuse did something extraordinary. It began to fade, dramatically. Its usual fiery brilliance dimmed by nearly 2/3. Astronomers, both professional and amateur, were captivated and a little alarmed. Was this it? Was the giant star finally beginning its death throes? Was the long-anticipated supernova imminent? The Great Dimming, as it came to be known, sparked a flurry of speculation and intense observation. The cosmic drama was unfolding before our very eyes. A sudden change in a star that had been a steadfast beacon for centuries. Theories abounded. Some wondered if the dimming signaled the star was collapsing, the precursor to a cataclysmic explosion. The internet buzzed with excitement and a touch of cosmic dread. If Betelgeuse went supernova, it would be the astronomical event of a lifetime. A Titan's life cycle, the fiery forging of a supergiant. Stars are born from vast clouds of gas and dust. Gravity pulls this material together. It compresses, it heats up. Eventually the core becomes so hot and dense that nuclear fusion ignites. Hydrogen atoms fuse to form helium. This is the main sequence, the long, stable adulthood of a star like our Sun. But Betelgeuse was not destined for such a quiet life. It was born massive, perhaps 15 to 20 times the mass of our Sun. And for stars, mass is destiny. More mass means a stronger gravitational pull, a hotter core, and a much faster rate of fusion. Massive stars like Betelgeuse burn through their hydrogen fuel in a mere few million years. Our Sun, by contrast, will live for 10 billion years. Once the hydrogen in Betelgeuse's core was exhausted, gravity began to win. The core contracted and heated up further. This ignited helium fusion, creating carbon and oxygen. The outer layers of the star expanded enormously, cooling as they did so. Betelgeuse swelled into the red supergiant we see today. Its ruddy glow is a sign of its relatively cool surface temperature, despite the furious furnace raging within its deeper layers. The inevitable cataclysm, when Betelgeuse detonates. When Betelgeuse finally explodes, it will be an event unlike any seen in modern astronomy. It will become incredibly bright. For weeks, perhaps months, it could shine as brightly as the full moon, maybe even brighter. It would be visible during the daytime. Imagine looking up at the midday sky and seeing two suns, our familiar sun, and the brilliant point of light that is the dying Betelgeuse. This celestial spectacle would be visible to everyone on Earth. A stark and beautiful reminder of the power and dynamism of the cosmos. It would rewrite the appearance of Orion for a time. The first sign of the supernova, even before the light reaches us, will be a burst of neutrinos. These ghostly, nearly massless particles are produced in enormous quantities during the core collapse. They interact very weakly with matter, so they will stream out of the dying star almost unimpeded, traveling at nearly the speed of light. Neutrino detectors on Earth, buried deep underground to shield them from other radiation, would register this sudden flood. This would be our first alert. The neutrinos would arrive hours before the shockwave reaches the star's surface and unleashes the incredible flash of light. What about the danger to Earth? Betelgeuse is about 650 light-years away. At this distance, we are safe. The main threats from a supernova are intense radiation, like gamma rays and the blast wave of material. Fortunately, we are too far away for these to cause significant harm to our planet or its biosphere. If Betelgeuse were much closer, say within 30 light-years, it would be a different story. The curious case of the spinning star. Betelgeuse's rapid pirouette. Red supergiants are expected to rotate slowly. As a star expands from its main sequence phase into a giant, its rotation should slow down, much like an ice skater extending their arms. This is due to the conservation of angular momentum. So, astronomers were quite surprised to discover that Betelgeuse is spinning much faster than predicted. It completes a rotation in perhaps a few decades, which is incredibly fast for a star of its immense size. This anomalous spin rate presents a fascinating puzzle. It hints at a more complex history for Betelgeuse than we might have assumed. What could make a red supergiant spin so quickly? One intriguing possibility is that Betelgeuse may have swallowed a companion star in its past. Imagine a binary star system. As Betelgeuse expanded, it could have engulfed a smaller nearby star. The orbital momentum of that companion would then have been transferred to Betelgeuse, spinning it up. This stellar cannibalism is not unheard of in the cosmos, and it would neatly explain the excess rotation. It adds a dramatic, almost violent chapter to Betelgeuse's life story, a secret hidden within its fiery depths. A beacon in the void, what Betelgeuse teaches us. Betelgeuse is more than just a dying star. It is a cosmic messenger. It carries information from the frontiers of astrophysics, offering us a rare glimpse into processes that shape the universe. By studying Betelgeuse, we learn about the final wave, dramatic stages of stellar evolution. We test our models of how massive stars live, how they change, and how they ultimately meet their end. Every flicker, every pulsation, every dimming event provides precious data. It helps us understand the intricate physics at play within these celestial giants. From nuclear fusion in their cores to the turbulent dynamics of their vast atmospheres. The prospect of its supernova is a source of immense anticipation within the scientific community. It will be a once-in-a-generation or perhaps once-in-many-generations event. When it happens, observatories worldwide will coordinate to capture every photon, every neutrino, every gravitational wave, if detectable. It will be an unparalleled opportunity to witness a core collapse supernova up close, relatively speaking. The data gathered will revolutionize our understanding of these cataclysmic events. The creation of heavy elements and the formation of neutron stars or black holes. Betelgeuse is a ticking clock, and its chimes will echo through astrophysics for decades. Our fascination with Betelgeuse also speaks to something deeply human. We are drawn to the grand, the mysterious, the powerful. We look to the stars and ponder our place in the cosmos. Betelgeuse, on the verge of a spectacular transformation, embodies the dynamic and ever-changing nature of the universe. It reminds us that nothing is permanent, not even the stars. It connects us to the vast timescales of cosmic history, far beyond our everyday experience.